Okay, so we are in the fifth video. Okay, so it's about real-time scheduling. So the scheduling in real time depending on two things. Okay, whether a system perform a schedulability analysis. Okay, so if yes, then it can be do it by static or dynamic. Okay. And then whether the result of the analysis itself produce a scheduler plan according to which tasks are dispatched at runtime. So basically, these are the survey being made. Then this is the one that the scheduling approaches need to be or follow, which based on the real time system characteristic. Okay. Okay, so based on the previous consideration, we have 4 classes of real-time scheduling algorithm. So the first two are static and the second one are dynamic. So we will look at each one of these in the next slide. So we have static table driven scheduling. So this static table scheduling, okay, it basically applicable to tasks that are periodic. So there are some information such as periodic arrival time, execution time, and also all of these are needed so that it's able to do the scheduling. Okay, so in this kind of algorithm, okay, normally they are use the earliest deadline first or other periodic deadline technique to apply with this scheduling algorithm. Okay, the second one is static priority driven preemptive scheduling. So this make use of priority driven preemptive scheduling mechanism, which common to most non-real-time multi-programming system. So this is being applied in an offline or non-real-time system. Okay, so but then in real time, priority basically related to the time constraint associated with each task. So meaning if the task need to be executed, okay, after 1 hour started, so it need to be finished by that. Okay. Right. One example of this approach is the rate monotonic algorithm, which assigns static priorities to tasks based on the length of their periods. So if the process or the task has like longer period, it will have lower priority. Okay, right. Okay, so these are the dynamic scheduling algorithm. So the first dynamic is basically when the task arrive, okay, so before its execution begin, okay, this scheduling will create a schedule, okay, that contain the previous scheduled task. So basically it will use the information of the previous scheduled task to create a schedule for this new task. Okay, so if the new arrival can schedule in that such a way that its deadline are satisfied and that no currently scheduled task miss, okay, no currently scheduled task miss a deadline, then the schedule is revised to accommodate the new task. So because of course, okay, the previous task and the new task will be might different, but we can use that as ground rules, right? Example, something like that. Okay, so the second dynamic scheduling is dynamic best effort scheduling. So this approach has been used in many real-time systems. Okay, so this is based on the characteristic of the task. Okay, so it's basically priority based on the characteristic of the task itself. So some form of deadline scheduling is typically used. So in order to know that the task must be complete, okay, the deadline must be complete at what time, okay, typically the tasks are aperiodic. So no static scheduling analysis is possible. So must be used dynamic. However, there is a major disadvantage because if using this, okay, until a deadline arrive or the task complete, we do not know whether a timing constraint will be met. Okay, because we are doing it in best effort. Okay, so just execute because it's kind of uncertain. Okay, so we do not know whether a timing constraint will be met or not because it's a periodic, right? So for example, if the deadline is at time 10, but this task is keep coming and we are unsure whether it will finish by the time 10. Okay, but by using this scheduling, it's very easy to implement. So that is why most of the real-time system using this dynamic best effort scheduling. Okay, so deadline scheduling. Okay, real-time operating system are designed with the objective of starting real-time tasks as rapidly as possible and emphasize rapid interrupt handling and task dispatching. So in real-time scheduling, they really want to make it start, okay, and can be complete within the time. Okay, so it's called that complete at the most valuable times. Okay, they're not really concerned about the speed. So priority is the what you say the information, okay, that will help to identify which task to be started first. Okay, but it does not capture the requirement of the completion, so whether it should start or not. Okay, so you have to know the priority and also consider the deadline information. So what are the information used for deadline scheduling? We will see in the next slide. So we have like 7 in the slide. Okay, so the information that can be used for deadline scheduling is ready time, starting deadline, completion date, deadline, processing time, resource requirements, priority, subtask scheduler. So priority is not only the one that information can be used, but we have others that can basically giving the information so that it will able to schedule the real-time task. Slide shows us, okay, execution profile of 2 periodic tasks. So we have task A and task B. Okay, task A has been divided into each process 1, 2, 3, 4, 5 and also B. So the arrival time for, because it's periodic, we can predict the arrival time. So 0, 20, you have the pattern, 20, 40, 60, 80 and so on. As B, 0, 50, 100, 150 and so on. See? So the execution time given to you is 10. And for B is 25. And also given to you is the ending deadline for each process. Okay? So by having this information, so this is the slide showing us the scheduling of periodic real time with completion deadline. Okay, so we put all the information like this one, A1 starting at 0, okay, arrive at time 0, and then we have the execution time is 10, so it will require 10 times, okay, and then followed by A2 arrive at 20 requires 10 times, so we put all in the table. Then B1 arrive at 0 and then finish with 25. Okay, B2 arrive at 50, arrive and then requires 25 as well. Okay, and then put all the information of that line. A1 deadline is here, A2 here, B1, and all in one. We have 5 for A, process A, and 2 for process B. Okay, so this is only translating the information from the table into the graph. Okay, so with using fixed priority scheduling, which A has priority, okay, we just look at the A1. Okay, so A1 has priority. So A execute until 10. So B arrive. So B can execute, okay, until 20. But then now A has arrived. So we consider A to execute first because A has the priority. So we bring out B1 and then bring A2. A2 until time 30 because it requires 10 time, right? And then B1. B1 continue back again because we have remaining 15. So put in B1, but suddenly A2 arrive. So we bring in A3. A3 arrive. So we pause B1 and then we bring in A3. At time 50, however, when we want to consider B1, B1 has that already reached the deadline, so no need to. So B1 cancel. Okay, and then we go to what the process that has arrived. So B2. So we bring in B2 until time 10 because we need to stop giving the way to A4. So A4 arrive, A4 until time 10, and then we continue with B2. Okay, when B2 after executing for 10 times, A5 arrive, so giving the turn to A5, and then finally we have B2 at the end with time 5. So with using the fixed priority scheduling for A has priority, we can see that we have B1 miss. Okay, in total, okay, we have 7 process, B1 has missed. Okay, using the same way that we did previously, but this time where B has priority. Okay, so when we consider B has priority, okay, with this information A1 and B1, so we will execute B1 first. So B1 execute until 25. At time 25, A1 has deadline, so A1 no longer able to execute, so we cancel that. And we can see that A2 arrive, so we execute A2. After finish A2, there is no process available to execute, so it's idle. And then we see A3 arrive at time 40, so we execute A3 until time 50. Then B2 arrive, we bring in B2 execute until the end. Okay, so at B2 we can see now which is the one that available, A4, right? But then what happened to A4? If we bring in A4, A4 cannot be executed, meaning it cannot be complete because the deadlines is already reached, nearly reached to deadline. So that's why this one become idle. A4 could not be executed, right? So then we continue to A5 when A5 arrive at time 80. So by using fixed priority scheduling, B has priority, we can see that 2 process has missed. Okay, right. So we can consider that when we use A has priority, only 1 process missed. Okay, but then if we use B as priority, we have 2 process missed. Okay, let's see the combination of 2. Okay, earliest deadline scheduling with using completion deadline. So we consider both process. Okay, so A1 execute. After A1 execute, B1 arrive. So we execute B1. Okay, and then suddenly A2 arrive. So we can see that we compare B1 and A1. A2. which one having the nearest deadline? Nearest deadline is A2, so that's why A2 execute first. So when A2 execute until finish, then we continue B1. Okay, continue B1 until time 40, we have A3 arrive. So comparing the A3 deadline and also B1 deadline, so we can see that B1 has nearest deadline. So we will basically complete the B1 first. Until B1 complete, then we take A3. Okay, when A3 execute, B2 arrive. So we compare the deadline. A3 deadline is nearest than B2. So that is why A3 continue first. Then B2. B2 execute until time 60 and then we have A4, right? So we compare A4 and B2. Which one having the nearest deadline? So A4. Then we preempt B2 and then we bring in A4. A4 will continue until finish at time 70 and no one here, so we just continue with B2. B2 execute until time 80. Okay, then we compare B2 and A5 deadline. Since they are having both similar deadline, we will consider the one that arrived first. So B2 will continue, okay, and then we continue A5. So from this, we can see that, okay, both process, okay, can fulfill, okay, their deadline when using the last, okay, basically considering both completion deadlines. Okay, so in the previous slide, we are looking into example 2 periodic tasks. Okay, so we finish with that. We go to the multiprocessor scheduling in Windows. Okay, so Windows support multiprocessor and multi-core hardware configuration, but then not all of the our machine that support hyperthreading, where you need to activate in the BIOS. Okay, if you remember, some of you having difficulty in executing the virtual machine, where you need to enable hyperthreading, so it's allow the virtual machine to execute. Okay, so the threads of any process can run on any processor. Okay, so if you have like multi-core, so that thread can run on any core that available. So normally now we have the quad core, okay, dual quad core meaning 8 core. Okay, but then dual quad core mean we have 4 cores, which one core having 2 subcore. Okay, and then multiple threads from the same process can be executing simultaneously on the multiple processes. So basically in multi-core Windows, okay, they can execute multiple threads, okay, simultaneous. So many multiple threads from same process on a different core. But then if most of the process only has one thread, so there is no like different if you have different in terms of the performance of that single process, because we still execute that in one single core. Okay, and in Windows, basically, as I mentioned previously, it's using the highest priority thread, right? Okay, so meaning the high priority will be execute first. Okay, so there's not much about details about Windows. The rest you can read. And then you can experience by looking on your OS on your own, okay, by looking at how many cores you have and how the status of your current core, okay, that is currently running. Okay, for summary, in multiprocessor and multi-core scheduling, we have the granularity, the design issue, we have the process scheduling, thread scheduling, and also some of it about the multi-core thread scheduling. Okay, and then in also we are not looking into the details about Linux scheduling and Unix scheduling and also Windows scheduling. Okay, so we're looking into multiprocessor and multi-core scheduling and also the real-time scheduling. So we have discussed about the background, the characteristic, the real-time scheduling, and using the deadline scheduling as well. Okay, so that's all for this topic. If you have question, then you can ask the lecturers to help you out, right? So that's all. Thank you and have a good day.